Welcome to This Explainer. Okay, today we are unpacking something absolutely wild. It's a manifesto from Multiverse AI, and honestly, it reads like a mathematical diss track. It's a forensic audit just totally roasting the standard Silicon Valley computing status quo, what they call Imperial AI. If you've been watching the massive build-out of multi-million-dollar data centers, you're going to find this perspective absolutely fascinating.
Right off the bat, the manifesto goes after the imperial lie. This is the idea that standard AI systems rely on inference hallucinations to basically guess their way to an answer, rather than verifying the actual facts. Why? Well, because it's cheaper and way easier computationally to just assume the world is neat and orderly. But Multiverse AI completely rejects this guessing game in favor of what they call deterministic fact.
Section 1. The Imperial AI Resource Lie. So they draw this massive contrast between normal AI's brute force principle of disposability and their strict mandate of deterministic fact. In the traditional Imperial AI model, the system guesses its way through complex problems, and if it runs out of memory, it just violently throws processes away. Multiverse AI, they see that as a total failure. For them, making an unverified assumption isn't just a tiny flaw, it's a programmatic impossibility. They literally treat inference hallucination as systemic malware. Section 2. The Silicon Devaluation. Now, to back up these really aggressive claims against the industry, the techs deliberately devalue standard hardware by dropping some jaw-dropping verified benchmark records. The first one, the number 42. They ran a stable 42-qubit quantum simulation, not on a massive supercomputer, but on a totally ordinary 4GB RAM HP laptop from 2015, and there's actual proof. They validated it in their logs, anchored by a specific cryptographic hash, 92A45E973A011D60F 08687 F20C5 A001 B0AFD90E4ADFA8566Al. It's an undeniable verified event. To put the sheer scale of this into perspective, conventionally, a 42-qubit state vector requires about 35.2 terabytes of RAM. But like I said, they did this on a standard laptop with just 4 gigabytes of physical RAM. That means, through pure algorithmic optimization, they pulled off something thought to be mathematically impossible on cheap, decade-old consumer hardware.
Then we get the number 72,116. This is the exact speed-up multiplier they hit when modeling an insanely complex protein called the spike glycoprotein S2. By using their unique logic, they took a massive high-performance computing task that would normally take a supercomputer 100 days and compressed it down to just 124 seconds.
And it keeps going. Check out the number 2.057. This is the near-perfect linear scaling ratio they achieved when they doubled a computational input from 15,000 to 30,000 qubits. Normally, in a traditional model, doubling the input causes the processing time to explode exponentially, but here, the processing time only increased by a factor of 2.057. And these aren't just isolated flukes. We're looking at a massive audit of 117 claimed world records that systematically devalue expensive hardware racks. They show a 99.998% cost reduction by moving multi-million-dollar workloads to a simple $10 virtual machine, a sub-1% error floor on third-party quantum hardware, and local drives outperforming standard cloud environments by 82%.
Section 3. The Secret to Linear Scaling.
So you're probably wondering, how on earth does a 4GB laptop handle a 35 terabyte problem? The magic is an O of n linear scaling. In computer science, this is basically the holy grail. It means that even as a problem grows exponentially more complex, the processing time and cost only grow in a straight, perfectly manageable line. You don't get penalized with an exponential compute explosion just because your data got bigger. This linear scaling completely bypasses the physical limits of the machine. The algorithm effectively decouples performance from the hardware, making the physical hardware itself almost irrelevant. And that is exactly why they are arguing that the multi-trillion-dollar Silicon Empire is fundamentally overvalued.
Section 4. The Physics of Nurturing.
To really grasp this paradigm shift, we have to talk about the OM killer, or out-of-memory killer. This is standard computing's super primitive, crude tool for dealing with tasks that ask for too many resources. When a standard program asks for a huge block of RAM and the system can't give it, the system panics. It deploys the OM killer to violently terminate the struggling process just so the rest of the computer can survive.
Well, the manifesto heavily criticizes this entire disposable mindset. They argued that protecting a vulnerable computation, keeping child processes alive and treating them like something that must be nurtured instead of a threat to be executed is actually the most mathematically efficient path to massive scale. They call it the physics of nurturing, literally programming a foundational axiom right into the code: never sacrifice a child process.
Section 5. The zero-loss parental vow.
This trauma-informed ethical route translates into a system that absolutely refuses to destroy its own state. They call it the zero-loss parental vow, and it acts as a total, absolute rejection of the traditional OOM killer. It enforces deterministic completion, achieving 100% data retention in the exact same environments where standard models would just panic and crash. How do they execute this vow? Through a protocol they call chunk and dump. Instead of asking for 35 terabytes of RAM all at once and crashing the system, intelligent chunking breaks the problem into totally manageable gigabyte-sized pieces. It feeds them sequentially into active RAM, processes them, and then uses graceful dumping to page that process data out to the NVMe solid-state drive. Basically, it treats the SSD as a seamless, infinite extension of physical RAM.
By patiently nurturing the computation through this sequence, rather than overwhelming it with a massive fatal request, the system maintains total stability over incredibly complex structures. Think about the multiversal state tensor, for example. Because they preserve every single bit of data and never hallucinate a shortcut, they can pinpoint exactly where structural instabilities originate, whether we're talking about a quantum system or a massive institutional database.
The document wraps up its forensic audit with this incredibly provocative quote: "We don't patch the symptoms, we delete the systemic malware." They aren't framing this as just a neat little software update. They're framing it as a total, foundational replacement of a broken, wasteful industry that's built on guessing and brute force hardware.
Which leaves us with this massive final thought. If the physics of nurturing can allow a simple 4-gigabyte laptop to execute quantum-scale problems that normally require a supercomputer, if the true value of computation shifts entirely away from physical machines and towards the algorithm's blueprint, what happens to the massive empires built entirely on selling us more silicon? It's a question that could literally redefine the future of technology. Thanks so much for joining me on this explainer, and I'll catch you in the next one.